September 14th, 2015. The day literally sent a ripple throughout the scientific community and made headlines around the world. That ripple was the discovery of a gravitational wave. Now, if you're like a lot of people, including myself, you probably read the headline and thought, so what? Well, let's unpack that for a minute. Gravitational wave theory goes back 100 years to Albert Einstein. It was linked to his theory of general relativity. Now, if you don't think the culmination of a 100-year prediction is a feat in and of itself, let's look at some other predictions that didn't quite hold the test of time. For example, in 1955, prominent publisher Variety magazine said that the rock and roll genre of music wouldn't last past June of that year. In the scientific world, look no further than Lord Kelvin William Thomson, who said that, quote, "Radio has no future, heavier than air flying machines will not exist, and the X-ray will be no more than a hoax." Well, you don't need to be much of an expert to know that those were all incorrect and have huge implications on our day-to-day lives, much like this discovery. So what is a gravitational wave? Well, it's the wave emitted with space-time curvature and the collision of black holes. Now, if that's such a big deal, why haven't we heard about it until now? Well, scientists have actually been working on this for quite some time. In fact, in 1993, two American scientists, Joseph Taylor and Robert Hulse, discovered binary pulses which, according to Einstein's theory, would give off the same radiation emitted by gravitational waves. Now, if Einstein was so smart, why didn't he just figure this out himself? Prove his theory. Well, he didn't have LIGO, which is the Laser Interferometer Gravitational Wave Observatory. Currently, there's two facilities in the United States. They're funded with millions and millions of dollars by government and have over 1,000 scientists working for them nationwide. Cumulatively, they've been working on discovering these waves for the last 50 years. So it's no small feat to finally hear the chirp that we heard. But why now? Well, it's a culmination of timing and technology. So, the gravitational waves that we heard are actually from the collision of two black holes that occurred 1.3 billion years ago and over 1.3 billion light years away. The timing part comes in because the ripples from that collision are just reaching us now, and we have the technology to actually detect them. To give you a comparison of those black holes respectively, they were both 29 times and 36 times the mass of our sun, and the cumulative generated light given off by the collision of those two black holes was actually more than all the light of all the stars in our galaxy combined. So it's quite a big deal. Now, astronomers, physicists, scientists, they've likened these gravitational waves to, it's like studying the universe is like going to the orchestra without hearing the sound. The sound has been heard in the form of a chirp of gravitational waves. Scientists can now study matter in the universe that doesn't emit light, things like dark matter, which is going to completely reshape the way we think about our universe. Now, if you don't think that affects you practically, well, it doesn't. You can get up, sip your coffee, go to work. We're not going to be flying around with jetpacks like the Jetsons anytime soon. But if history is any indication, discoveries like this usually have monumental implications. If you look at 1895, William Röntgen actually was playing around with cathode ray tubes and stumbled upon X-rays. They're still a prominent tool used in modern medicine throughout the globe. In 1885, radio waves were discovered, which revolutionized the telecommunications that we all share. And for Einstein's theory of general relativity, well, look for no further practical application than your GPS, either on your phone or in your car or in the satellites probing space. So there is a lot to be said for these discoveries. What the specific implications are, we don't currently know, but you can rest assured history tells us there will be some. Now, in terms of science, it's not just the physical evidence, but it's a way of thinking. What Einstein did with his theory of general relativity is that he cracked Newtonian thinking, which existed for about 200 years. He shattered that theory with his general relativity. And now, with this new way of thinking, with this new evidence, we can actually explore the universe in a much more comprehensive way. As for myself personally, when asked if I care, when I was a kid, I used to think that we didn't really need NASA. I I used to think that because if people were starving in the world, people were going hungry right here on Earth, why are we worried about hearing some chirp that happened a billion years ago, a billion light years away? Literally. What's it to us? Why don't we fix the problems around us? But I've come to the conclusion, formatively in my years, I guess, studying science, is that I think Carl Sagan said it best. He said, each one of us in the cosmological perspective is precious. If someone disagrees with you, let them live, because you'll never find another one in 100 billion galaxies. It's not just a way of thinking, it's a philosophy, and the two are very intertwined. To not explore space would be to leave our curiosity behind, which is much more, I guess, integral and necessary into our society than we think it is in our day-to-day lives. So the exploration of space is one that furthers the human endeavor. And if you don't, regardless of what you think about gravitational waves, discoveries like these have the ability to form and shape humanity much as they have done in the past. Without Einstein's general relativity, we wouldn't have the technology that we have today. Can you imagine if we didn't have X-rays or radio waves? So take it with a grain of salt. It may not affect you in the next week, days, or months, but nevertheless, this was a revolutionary discovery. Sweet, I can use that.